I'm CK. Today we've got a kit from Velleman that looks to be both instructional and useful. This is the LED Buddy, and what it is it's a little device that you put together that will test the polarity of an LED, tell you the forward voltage of the LED you're testing, and tell you what series resistor you need to get the right current flow through the LED, which is all very convenient, and I think you can run it on a 9-volt battery. So that's all very cool. We'll put it together, see how much we learn, and put it to use. Hope you enjoy the video. So let's see what's in the box. LED Buddy measuring instrument. LEDs, it's a level 2. Help you design electronic circuits that include LEDs. 8x2 LCD, auto-calculates series resistor, detects polarity and measures the forward voltage, and uses 12 volt. Uses 9 to 12 volt. So you can use a 9-volt battery to power it. Let's tear the box open. Piece of paper. 9-volt battery box. It looks like it's got a daughter board pretty much all the way populated. We'll get the box ready for recycling. Actually, I heard something rattle in it. I think I just threw the circuit board over my shoulder. Yeah, I did. So we'll grab that back. There's the circuit board. It looks substantially better quality than most Velleman circuit boards, including the solder holes are all through-hole plated. Nice cathode-anode place. The values of the components are not listed, but let's see, we've got a switch, a bunch of resistors, current and voltage. I'm not sure what that's going to be. Might be trimmers. Transistor, an IC, and then we've got this guy. But first, before I get too far ahead of myself, I'll open the piece of paper up. It's the typical Velleman style, and all pretty much standard, nothing too crazy here. It does say, so we've got the header for the display, but I don't know what, it doesn't say what IC it is. I'm sure it'll be visible once we get it out of its packaging, but I don't know what it is right to start. So let's look at this bag first. We'll get the display in a little bit. Hack and slash the bag open. Nothing else in the bag. Now, are you going to bet with me that it's an Atmel chip? No, it's a PIC 16F1503. I'll look that up. I believe this is micro. I know the name of it. It's got a logo that looks like Motorola, but it's not Motorola. It's another Chinese manufacturer. And you can barely see there's a yellow highlighter line on it that indicates that it's been programmed. Here's all the resistors and a couple of 104 caps. So resistors, diode, 104 caps. Pin header. This should be a 427 or 4700. I can't really read it. I'll look at it closer. There's one trimmer, and this is for the voltage on the board. These will be the two trimmers for voltage and current. That's interesting. And is this this is a voltage regulator? Yeah, this is a 78L05 voltage regulator. 5 volt. And here is, this is the display and the processor and all the intelligence. So the processor is all potted down under there, so we won't know what that is. Interestingly, there are 2 resistor pads that are open. I may see if I can find what this is, it might be hard to do because there's no, well, I'll take a search, who knows, I may get luck and it'll just dance out at me. So, got the IC there, and there's the switch, just a regular little switch. So the display is a nice little display, and the driver is under there, of course. Again, and there's a couple of jumpers here, too, that are not jumped. Two of them are, J4 and J3 are jumped, but J5 and J6 are not. And then it looks like we've got ability to ground things to a frame if you're putting it in a case. This looks like an interesting little module. I may look this up for other devices. So that's what we've got. Looks like assembly will be pretty straightforward. Nothing too critically challenging about it. And we'll see how it goes. So, oh, is there a transistor here also? Did I skip over the transistor? Oh no, it's 2 voltage regulators. So we've got we have the LO5, which I already talked about. This is an LM317. I don't know what that voltage is. I'll have to look that up too. So I'll get the soldering iron heated up, look up these couple of parts, and we'll put this thing together. Alright, we'll start with the resistors, 1 diode, and the 4 104 decoupling caps. And the way that Velleman does this is they put all the straight line components in one strip instead of having some resistors, something else. They put them all in one strip, which is convenient. They must have one of these stripping machines, which, I don't know, maybe I should get one. I don't know. And generally they're in the order that they're in the assembly guide too, even though you do want to double check that. And again, I'm very pleased with this, the quality of this board. This is a much better board than they typically have in their lower end experimenter kits. So we'll just take these 10K resistors, and there should be 4 of them, right? R1, R2, R3, R4, yep. And we'll put 1 on the board first to see how the board takes solder. And this will be R1, and R1 is over here. And again, I expect it to take solder very well. One thing you might have noticed here, there isn't a lot, there's no documentation on how to actually work this. I think it'll be self-explanatory, even though I'm not quite sure what the trimmers for voltage and current are. I'm going to assume that it doesn't automatically ramp up voltage until the LED starts glowing. You'll have to do that yourself. And the current knob, I'm not quite sure. So that went together really well. Let's see if it wicked through. As you can see, the solder wicked through the hole too, which is the whole point of through-hole plating, to give you solder all around the lead. So number 1, it's really good conductivity, and number 2, it's not going to corrode over time and lose connection. So that's the one that I can talk about. Now I'm going to go and do all the rest of the resistors. And there aren't that many, so this will be a short resistor time for tonight, but still enjoy resistor time. And that's the resistors. So next we'll put the little Schottky diode in. It's a 4148, very common. You'll run into them all the time, and it's got a little black line on the end that'll go to this thick white line on the circuit board to make sure the polarity is right. trying to get it flat on the board because sometimes I spaz on that. Then we've got the little 104 decoupling caps that now we'll get this other 1 microfarad cap on a little paper tape, and this one I won't try and fight it out. I just clip it off. Why wrestle with it? And this goes in the other, there it is, C1. IC socket on before this, doesn't much matter. Doesn't much matter. But we'll go ahead and put the IC socket on. Standard IC socket. Of course, standard for me means it's got some cat hair on it. So we'll put it in the holes. I'm going to lay it down on the board this time because it'll sit flat. And I'm going to do one leg. Let the solder cool. Pick it up, take a look. And as you may be able to see, it's very out of kilter. It's not quite in the holes. So I will reheat that solder pad and just push on the socket, remove the soldering iron, and that flattens it right back out. Easy as 3.14. Now we'll put the switch on, the power switch. I'm going to trim those leads off that capacitor in a little bit, but I'll do this power switch first. This is another one that I'm going to do one leg on. Take a look, and that is flat, so we're good. Go ahead and do the other two leads. Now we've got two voltage regulators. We've got the 78L05, which is again the 5-volt voltage regulator, and then we've got this LM317LZ. I don't know what that is. I should know what that is. LM317LZ data sheet. It is oh, it's an adjustable positive voltage regulator capable of supplying in excess of 100 milliamps over output range of 1.2 volts to 37 volts. This voltage regulator is exceptionally easy to use and requires only 2 external resistors to set the output voltage. Well, that's kind of nice. I'll remember that. No, I won't. But when I'm making my own power supply in the future, I might remember, hey, there was a little voltage regulator, low amperage voltage regulator I should look at. Now the two pots. We've got one 10K one. That would be this one that says 10K. That'll go in variable resistor 1. And the other one is 470 ohms, and that'll go in resistor 2. That's the current setting resistor. Now we're going to put the 16-pin pin header going up on this end, like so. Those look all good. And we'll put the IC on the board, the little microprocessor. Microcontroller. And make sure we got the notch going the correct way. And we do. It'll go like that. All securely in, no pins bent. Now we're going to take this female pin header and put it on the display board, like so. And I'm going to need a little more solder. I thought I could get away with using just my scraps, but didn't. And if you go through as much solder as I do, you use every bit you can. And that's that. Now, before we put these two together, we're going to put the battery box on here. And I'm going to see how it goes on first to decide how I'm going to put the wires on. I think it'll go this way, won't it? Yes, it will. It'll go just fine that way, and then it'll kind of stand up, but we're not going to be standing it up, I don't think. So we'll take our little screws and drop them in here. Put it in just a little bit. Actually, it went tighter than I thought, quicker than I thought. Now tighten all the screws down, not too tight, not gorilla tight, because it's metal going into plastic, so you don't want to strip the plastic out. Now we'll put the wires through. Black is on this side. It's written on the other side of the board, but I can see it. Put that there. Grab my locking tweezers to hold that in place. Yeah, I could trim these leads down, but I don't really care. Now we've got two standoffs to support the display. And I'll just make those finger tight. This device is not going to be undergoing a lot of stress, so I'm not too worried about it. Now we'll mate the board, like so. Push it tight down on those pin headers. Ta-da! And we've got a little, two more screws here. Now we put these little pegs in here so we can turn the variable resistors. Now I'm going to go get some LEDs for us to try this thing with. Hold on a second. Okay, I've got a blue, a red, and a white LED. All should have different forward voltages. So let's turn this guy on. Okay, it comes up, says LED buddy, and then it says touch LED. So we'll take this red LED and touch it like so. 2.2 volts, 26 milliamps, 4 volts, 68 in a 4 volt circuit. It'll take a 68 ohm resistor. Let me turn the voltage up. 24 volts, it would take an 820 ohm resistor. Take the current up or take it down, and then if the current's only 4 milliamps, it'll take a 5K6 resistor and forward voltage of 1.9 volts. Okay, so that's what a red's doing, so we'll leave that on 24 volts and 2.0 volts. So that's that, what is it, the 317LZ power regulator is getting us at 20 volts. Now we'll put this blue one on here, and that's 2.8 volts. So you can see it's slightly different. 2.0 for red, 2.8 volts for blue, and you can see that the current limiting resistor, oh, they're going to be the same on that one, I think. Did I get that right? Yeah. So that's a 3K9, and this one would take a, I mean, you can do the math for this. This is not hard math, but this is 3K3. Now let's try the white one and see what that has to say. And that's 2.8 volts and 3K3. I'm going to take this down to say a 5 volt nominal output. So you would take it down to, as you can see, 0 volts doesn't do anything. 15 volts, I'm going to take it down to 5 if I can. This is a little, you have to have an LED on it to set the voltage. Yeah, that's 5 volts. Forward voltage of 2.8 volts, 6 milliamps, 390 ohm series resistor for it. So there you go. I hope you could see that okay. Let me go ahead and do this again real close up. So I'm doing this again real close up. And I will take the little film off it because it's throwing a glare back at the camera. Now you should be able to see it really well. I'm sorry. So the red LED, 2.0 volts, 470 ohm resistor at 5 volts. This also tests your LEDs, so it's real handy to have. 2.8 volts, 390 ohm resistor at 5 volts. And the white one, 2.8 forward voltage and 390 ohm resistor at 5 volts. So there you go. It's a very handy little device actually. So I'm going to keep that here on my workbench top to see how it all, to just have it handy to test LEDs. It's actually going to be slightly easier than using the meter. So a good little kit from Velleman. I think it costs about $30 US, and I got it from jamco.com. There will be a link in the description. So good little kit, and I hope you enjoyed the video.